Okay, so let's look at this concept of an infinite sum by trying to check out a couple infinite series here and see if they converge or not. So one example is this series right here. Right? 1 over k times k plus 1, and we want to take the sum from k equals 1 to infinity. And we want to ask, does this converge? Does this diverge? If it does converge, what does it converge to? What is the sum of this series? Right? So what I'm going to suggest we do is the same thing we did when we were trying to find the limits of sequences. Right? We want to try and find a pattern and try and take the limit of that. So for a series here, we need to find the sequence of partial sums, right? So for us here, AK, the general term of the series, is 1 over k times k plus 1, right? This is our sequence that we're adding up for the infinite series. So S1 is simply going to be A1. So we just plug 1 into this formula here. This is 1 over 1 times 1 plus 1. So that's 1/2, right? Let's look at S2. That's going to be A1 plus A2. Okay. So this is 1/2 plus, this will be 1 over 2 times 2 plus 1. So that's 1/2 plus 1 over 6. Okay. If we add these up, this is going to be 4 over 6, or 2/3. Okay. Let's look at S3 here. Right? S3, this is, I'm going to look at this in a different way now. This is going to be S2 plus A3. All right, I'm going to use that just as a little shorthand to say, S2 is A1 plus A2, and then we're going to add A3 to that. Right? So I'm doing that because I just want to write 2/3 here. I don't want to write, 1/2 plus 1/6, because that'll get a little bit exhausting. All right? We want to try and keep it as simple as we can. All right? So 3 plus 1. So this is 2/3 plus 1 over 12. Right? So if we add this up, this will be 9 over 12, which simplifies to 3 over 4. Right? Can you see the pattern here yet? So think about what that pattern might be. Pause the video if you need to. We'll do one more after this to verify that, okay, that pattern is hopefully what we think it is, and then we'll go from there. All right? So S4, this is going to be S3 plus A4. Right? So that's 3/4 plus 1 over 4 times 4 plus 1. So that's 3/4 plus 1 over 20. Right? So this is going to be 16 over 20, which is 4 over 5. All right. So hopefully, by doing this now, you can see the pattern that's emerging here. Right? So the pattern, hopefully, you see, is going to be n over n plus 1. Right? This is the pattern for the partial sums. Because look here, it's 1 over 2 for index 1, 2 over 3 for index 2, 3 over 4 for index 3. Right? And if we keep observing that, hopefully you can see that this is, in fact, the formula for the partial sums. So let's try and do this limit. So the series, let's just write this down. Limit is n goes to infinity of Sn. All right. So this is asking the limit is n goes to infinity of n over n plus 1. Right. So this here, it's completely up to you how you want to compute this limit, whether you want to use the limit command in Mathematica, use your knowledge from last semester's calculus course. Completely up to you what you want to do. But either way, you should find out that this limit is 1. So this means the series, come on. The series converges to a sum of 1, right? So we would say, the series from k equals 1 to infinity of 1 over k plus 1 is equal to 1, right? And there we go. So let's look at one more example here, just to see what else can happen. All right. Let's look at the series from k equals 1 to infinity of -1 to the k. All right. So let's look at this. Here, ak, the general term of the series, is -1 to the k. Right? Let's look at the sequence of partial sums here. So S1 is A1 is -1. S2, which is A1 plus A2, is going to be -1 plus 1, which is 0. S3, I'm going to use the same trick as earlier. That's going to be S2 plus A3. This is going to be 0 plus -1. Right? And that's -1. S4 is going to be S3 plus A4. So that's -1 plus 1 and 0, which is 0. So what we get here is a sequence of partial sums. This sequence of partial sums here, hopefully you can see, is -1, 0, -1, 0, -1, 0, so on. Right? The partial sums here keep bouncing back and forth, -1, 0, -1, 0, -1, 0. So the question is, does that converge? So think about that. Hopefully you'll see that this limit, as n goes to infinity of Sn, this diverges. Right? In this case, it does not exist. Remember that if the limit is plus or minus infinity, technically it doesn't exist, but we say, the limit is plus or minus infinity because that makes some kind of sense. But at either rate, if it's infinite or the limit doesn't exist, the limit diverges. Right? This sequence diverges because it doesn't converge to a number. Therefore, the sum also diverges. Right? If this limit diverges, the sum diverges. Right? And there we go. Hopefully, kind of the idea here for how to, determine whether a sum converges or diverges makes sense. Now, you might be suspicious that these examples seem to work out pretty conveniently. And you'd be right. It's not always the easiest thing to do by hand like this. Usually we're going to use some kinds of tricks to figure out, does this sequence converge? Does this sequence diverge? And the next week or so of lectures will be sort of committed to figuring out, well, when does a sequence diverge? When does a sequence converge? What kind of tests can we develop to detect these things? Right? So for the other videos, for this group of lectures, we're going to talk about two special kinds of series that are really easy to detect.